So we've done a little bit of stuff with logarithms. I'd like to talk about a few properties of logarithms today. And I think all of the first three you have seen in some form before. 3b you probably haven't seen, and I do believe that we did mention that you can't take logs of negative numbers. So I'm hoping that all of these are somewhat familiar, but I just thought I would give them to you just so you have them in your notebook. And I will give you a few quick examples. So here's a bunch of problems. Feel free to pause and try them on your own. Okay, so for number 1, we have log base 5 of 1. That's that top property up there. We know that 5 to the 0 gives us 1, so my answer is 0. Number 2, we know that 3 to the first power gives us 3, so that's the answer for number 2. Number 3, that's similar to my third law. In order to get from 3 to 3 squared, we just do 3 to the second, so my answer is 2. Number 4, that is this property right here. We end up getting 4. I do want you to recognize that for number 5, that is actually the same exact thing as number 4. It's just that I wrote ln instead of log base e, but keep in mind that ln is a log base e, so that is going to be 9. For number 6, that, remember, is the same as what we had in number 3. We know that ln is log base e, so my answer for that is 6. And then number 7, we have a negative exponent, so that one is a no solution. So we also have what's called the change of base rule, and this is useful if you, for example, get something like log base 5 of 57. That you might notice that you can't evaluate that in your head, and it's also really challenging to evaluate it on the calculator. So what we can do is we can change this to a base that your calculator does allow you to use, and then we can evaluate it there. So one way to rewrite this is using base 10. And remember, base 10 is when you have a logarithm. It's called our common log. It's a logarithm with no base is base 10. So in that case, my b, which is this little base down here, my b would be equal to 10. I would rewrite that as log base 10 of my 57, my x value, over log base 10 of 5. And don't forget that you can just evaluate these directly on the calculator. So you wouldn't have been able to evaluate the original thing on your calculator, but this you can. It is going to be approximately equal to 2.512. We can also change this to base e. And remember, base e, let's write this whole thing out. Base e is the same as ln. So we would write it as log base e of 57 over log base e of 5, which would give us ln of 57 over ln of 5. You're welcome to try that on your calculator. You will find that you actually get the exact same answer as if you changed it to base 10. So this is going to be really helpful if you have a log that you can't evaluate on your calculator. So now I'm going to give you some properties that are there. You'll actually find that if you take calculus in the future, they will be really, really helpful. So if you have two things inside a logarithm being multiplied together, you can actually expand them out to addition. If you have the two things that are in a logarithm and they're divided, you can change them to subtraction. And my favorite one is the power rule, where if you have an exponent inside of your logarithm, you can actually bring that exponent out front. So let's do a few quick examples. So for the first one, we have a product inside of our logarithm. We can rewrite that as log base 3 of 4 plus log base 3 of x. Then for number 2, this is the this one you can do using the power rule. I can take this 2 and move it out front, and I can rewrite that as 2 ln of x. 3, it looks like this one's really hard, but what you can actually do on this one is you can remember that the cube root of something is the same thing as that thing to the 1/3 power. If you remember that, then you can expand this out. You will end up getting 1/3 ln of x. So number 4 is kind of a long one. There's a lot going on in this one. And the first thing I want you to notice is we have stuff that is being multiplied. We have some powers. We have division. This one has a little bit of everything. So I'm going to go ahead and expand it out as much as I can. And I'm going to start, though, by working with that division bar. So what I can do is I can rewrite this as, so I have this thing on the top divided by this thing on the bottom. If you look back at our properties, we know if two things are divided, we can change that to subtraction. So I have ln of x to the 4th times z to the 1/2 minus ln of y to the 5th times w to the 3rd. Now what I can do is I can rewrite the this inside as addition because these are being multiplied, and I can do the same with that one. So when I do that, I will get ln of x to the 4th plus ln of z to the 1/2. I have a minus sign, so what's actually going to happen is this entire thing is going to be negative, so I get ln of y to the 5th plus ln of w to the 3rd. The last thing I can do is move my exponents out front. So I get 4 ln of x plus 1/2 ln of z minus 5 ln of y. I'm actually going to distribute that negative, so I get minus 3 ln of w, and that's my answer for that one.